Hello, everyone. We will be doing yet another hard problem today, and this one is on the easier side of the hard problems. It's called string transforms into another string. I haven't solved this problem before. Let's see. So, yeah, as you can imagine, we are given two strings, string 1 and string 2, and they have the same length. Figure out whether you can transform string 1 into string 2 by doing zero or mere conversions. Okay, in one conversion you can convert all occurrences of one character in string 1 to any other lowercase English character. Okay, so we are returning Boolean. And let's see the tests, right? So let's do ABCD and ABBD, and that's true. For obvious reason that we just need to change the C to B and it will be fine. Let's now do something CCCBBBD. This is also true because we are changing all the characters. Let's now do another thing and let's do ACBD, ABBD. This is also true, even though our C's are not at the same place. Okay. And let's now show something that cannot be converted. So ABCD, ACBD. This is false because we cannot convert this B to this like C and also convert this C to this B. Okay, so essentially, I think I have an idea about how to solve it. So we are traversing both strings, and let me just print those under one another, right? Let's maybe take this example. I think it's the most interesting one. So, and we have a point, and we are pointing to the same letter. I want to prove it's convertible if and only if there is just one type of unmatched pairs, position pairs, let's call them. So what I mean by that, right? We have all of those pairs of characters at the same positions. And here, for example, these two, right? Either they're matched and then we don't care about this letter, or they're not matched and then we do care about this letter. And it also doesn't, like, if string 1 can be converted into string 2, then string 2 can also be converted to string 1 by doing like a reverse operation. So here, let's say we encounter an unmatched pair, as I said. So this pair is now C and B. And we continue. And if we encounter the pair, an unmatched pair that is still the same, that is fine. If we encounter a pair that is a new one, then we are done. So basically we now say that there are two unmatched pairs, and if you have two unmatched pairs, you cannot make just one change because you now need to change two different characters so that after the conversion you get the string that you want. And you are always all occurrences of one character to any other. So I'm assuming that here we are changing all occurrences to the same lowercase English character. I have been assuming that throughout. Maybe they mean that we can convert all occurrences of one character to any other English character. Let's see. Oh, zero or more conversions. I see, I see. Zero or more conversions. That's a totally different problem. Let me start again. So, okay, this is when is this not possible? I think everything that I have written so far is still true, but that's just one conversion, right? What changes if we have more conversions? Well, we will only be blocked if we have a situation like this. Okay, let's do now A, B, C, D, E, and let's say A, C, 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 E. So this is still true because we can do two conversions, and that's fine. Those will be now like the letters, the same letters. That's good. But when it doesn't work, then, for example, we need to convert string 1 to string 2. That's important. Because then, if we, for example, have ACCCE and ABCDE, that's false. Because we can always convert all of those to the same other string at the same time. So here the order of operations might matter. Let me try to figure out an example. I'm thinking about whether there is a graph structure here. So a sequence of changes for each character to another character, and at most you have can you actually have more than 26 steps? Can you have more steps than there are characters in the string? Let's actually look at two situations, right? A situation like this, when we let's say we have AB to Z, and then we have the same string, but BC ZA. So I think this is false. Why I think this is false? And why I think any string that has fewer than 26 distinct characters is true. So if we, oh, no, it's not always true. If we need to change, yeah, so if the same character need to be mapped to several different characters, then it's impossible. So like this here, right? If we need to map several characters to different characters, so if there are, like we start collecting the pairs, we start collecting the pointers from the characters in the first string to corresponding characters in the second string. And all the same characters always need to be transformed to the same character on the other side, because otherwise it will be impossible. And that covers almost all of the cases. Because let's say we have something like this, but let's see A, G, B, C, D, right? So if they are all mapping, like the character, they're not two different pairings, like not two different pairings for the same character on the other side. So we have same characters on the other side for string 2, but we don't have similar characters here. So here we can always map to some other character, like let's say we can map G to F. There is no F here, right? So we first map to F, and since this character doesn't exist in the string, then we safely map it to F and then back to whatever character we need. And we can do it one by one with all of the characters. So if we read the rules, right? If all character 1, character 2 have no duplicates, no have at most one character 2 in the mapping, then if less than 26 distinct pairs, true. Now let's discuss this 26 distinct characters, right? So we just need to somehow map everything, and whatever character we change here, whatever character they change, we will be changing another character. We will be changing to a character that already exists in the string. That's what I'm trying to say. So then we will be getting in the situation like this. We will have two characters. We know that on the other side, all of the characters are distinct. But whatever we do, whatever the change we make, we will always create two duplicate characters here. So there will be two distinct characters in string 2, and the same character will be mapping to these two in string 1. And because of that, we can never do that. So that's fine, but we have shown when it's impossible to do that, even if we start with all the distinct pairings like here, right? But is it always like that when we have all 26 distinct characters in string A, for example? What if we don't have if we have all 26 distinct characters in string 2, then unless the strings perfectly match, it's impossible to create string 2. Okay. I'm now trying to think through if there are any other corner cases that I didn't think through, because I have shown some examples, but I haven't proved that these are the only possible scenarios. I can prove both of these statements. No, no, I think that's it. Let's try to implement this. Yeah, I think I should be clear about the running time and space complexity. Let's think about this. So, let's say n equals to length of string 1, for example, and then we have of n runtime, because we are just collecting the pairs, and we also need to calculate number of distinct characters in string 2. Yeah, and we also need to check if string 1 equals to string 2. So of n runtime. Then yeah, I don't think that's there. It's doable in of one auxiliary space. So of n space also for storing all the pairing mappings. Well, essentially, yeah, I think let's think about this way. Also, like 26 distinct characters, I'm assuming that in our alphabet there are just 26 distinct characters. I think this is correct, but if we need to generalize it to other alphabets, it will still work, but the 26 will be hard-coded. Okay. So first of all, let's just do if string 1 equals to string 2, we will be return true. Now for I in range length string 1, mappings equals dictionary if string 1 at this place already in char mappings, then if char mappings string 1 of I does not equal string 2 at the same place, then we can confidently say that we have found a different mapping, a new mapping, so the situation is here, and we can just return false. We will never be able to convert one string into another. But that's not all. We also need string 2 pairs will be set. So then we just say the same thing, but we do that. And finally, Okay, so we can simplify this. We can do this, and now we also need to do string 2 characters, add string 2 of at the same place. Okay, if return length of string 2 characters doesn't equal 26. So if we haven't found this situation, then if the second string contains less than 26 characters, distinct characters, we can always find a solution. Otherwise, we can never find a solution unless these two strings are already matching. So let's now process something. So let's do this as an example. Okay, so these two strings obviously are not equal. And by the way, I think there should be also a corner case that we haven't discussed, which is like, what if we have two empty strings? I think this is true. And in our situation, it also works because we process it here. So now for character mappings, we have ticked. For string 2 characters, we have a set. And for I in range, okay, so for all of those i's, let me just do this. So we have a pointer, we compare the characters. String 1 in character mappings, no, not yet, but now it actually is. So character mappings will be A maps to A. Now we will also be, by the way, adding here the characters, so there will be just A. A maps to A, then C maps to B, that's fine, and C maps to C, that's not fine. We will never get here because string I C will be in character mappings, and character mappings of this string I will be not equal because it's currently mapping to B. This will be B, and this will be C. So we will be returning false, which is correct. Otherwise, we would have continued, and yeah, in this situation, it would have been fine. Because B would have mapped to C and D would have mapped to C. Both are fine. Okay, let's see. Network error. Verifying that I'm a human. Okay. Accepted. And B, it's 93%. And also trying to reconnect 24 minutes. 24 minutes, hard problem on the first try. I think this is a win in my books. Thanks everyone. See you the next time.